Hello everyone, we're on Unit 3 Fractions. We're on day 2 of 15. We're looking at recognizing and generating equivalent fractions that has the root word equa, which means equal. Remember, we're going to stay focused on using multiplication and division to understand what a fraction is. And remember, inside your multiplication chart, these are your products or your multiples, and on the outside are your factors. So 12 has the factors of 2 and 6. 12 also has the factors of 4 and 3. 12 is a multiple of 3. 12 is also a multiple of 4. So we need to learn those terms to understand the language of math better. All right, these are our new vocabulary words. Go ahead and pause the video to take a look at what they mean. We have benchmark fraction, denominator, common denominator, what a fraction is, equivalent fraction in simplest form. And on the other side, we have partial product again, partition, the act of breaking up into parts, array, factors, product and multiples, and the commutative property. So today we're going to focus on what a fraction is, a number that names part of a whole or part of a group. So if you have a whole square, a fraction is 1 out of 3 of them, or if you have 3 pencils, there's also 1 out of 3 of those pencils. A benchmark fraction is a size, kind of like a compatible number, something that you know or understand well, so that way you can compare. And we'll look at the denominator. All right, let's give it a go. By the end of this lesson, you can recognize and generate equivalent fractions, and we're going to be also taking a look at some division. All right, let's start out with our first review problem. We're going to take 465 and we're going to break it up into 7 groups. Something you might not have realized is that this fraction, 465 sevenths, is also division. These two equations or expressions are actually the same. They represent the same operation. Here you're taking 465, breaking up into 7 groups, and here you have 465 that are broken up into groups of 7. So how do we solve it? Pause the video, give it a go, and then I will show it to you as well. All right, so here's the problem. 465 sevenths, or 465 divided by 7, broken up into 7 groups. This is what it looks like on your bar model. Here's your whole value, 465, and you broke it up into 1, 2, 3, 4, 5, 6, 7. All right, so that's what we're doing. So one of the ways we did it is we put it into a traditional division model. So this is 465 is your dividend, number coming to an end, and this is your divisor. All right, so one of the things that we taught you is to start breaking this up into groups of 7. So 7 times what number will give you multiples of 7 that you subtract from 465. Well, we look at the first digit, it's a 4. I can't take any 7s out of my 4. So I go to the second digit and I have 46. Well, 7 times 6 is equal to 42, right? So I could take a bunch of 42s away from 465, or I can recognize that if I use my properties of 10 and add a 0, I would add a 0 here, which makes 7 times 60 is 420. So I'm going to use that one because that's taking away quite a bit. And I'm going to use subtraction. 5 take away 0 is 5. 6 take away 2 is 4. Now I have 45 left. How many 7s can I take out of 45? Well, again, 7 times 6 is equal to 42. That's pretty close to 45, so I'm going to give that a go again. 45 take away 42 is 3. I can't take any 7s away from 3, so I have a remainder. If I can't take any more sets of 7 out, there's my remainder. So how many groups of 7 did I take out? I took out 60 groups of 7 with that 420 and 6 groups of 7, which was 42, which gave me 66 groups of 7 altogether. So what that means is if I take 465 and I break it up into 7 groups, there will be 66 in each group. But how many will be left over? There will be 3 left over. So 465 broken up into 7 groups is 66, remainder of 3. There's your review. All right, so let's take a look at some of our vocabulary. First of all, what is a fraction? Here's your whole number. You have one whole candy bar right here. All right, that's represented by the whole number 1. So if I was looking at my ones, tens, hundreds, all those numbers to the left of this decimal point, these are all whole numbers, whole place values. And then everything to the right are my parts, and we call them decimals. All right, so decimals are actually fractions as well. So when I take this whole number and I break it up into parts, I end up with fractions. Okay, fractions is F-R-A-C-T-I-O-N. T-I-O-N is the act of, and fracking is the act of breaking things apart. So right here, I broke apart the whole 1 into how many pieces? 2 pieces. And I have one of those 2 pieces here and one of those 2 pieces here. So I have a fraction. I don't have a whole number. I have parts. Now if I take this whole number and I break it up into 3 groups, each group is 1 out of 3. 1 out of 3. So this is 1/3, 1/3, 1/3. I have fractioned my whole into 3 parts. So this denominator, this number that is down, is actually like a divisor. That's what I like to think of it. And look at all these D's. This is the number that you have broken up your whole into equal groups. So I have broken up my whole here into how many groups? 3. 1, 2, 3. And this numerator is the number of parts that I have. So right here I have 1 out of 3. If I was to take both of these together, I would have 2/3, or 2 out of the 3 parts. So that numerator represents how many parts you have. The 3 is like a divisor. It literally is breaking up your whole number into that many pieces. So what is the denominator for 1/5? It's the 5, because I took my whole number and I broke it up into 5 pieces. What's the numerator in this case? 1, because I have one of those fifths. All right, so that's the numerator and denominator. A benchmark fraction are fractions as we get to use them that you may know better than others. All right, so it applies not only with these bars, like candy bars, but it also applies to your circles. So here I have my whole pizza, and I have broken it up. Let's take a look at the denominator. I've divided it into 3 pieces, 1, 2, 3, and each of these pieces is 1. All right, here I have divided my fraction into how many pieces? 2, and each one is worth 2 pieces. Here I've broken it up into 5 pieces, but one of them just fell off. So instead of having 1 whole, I actually have 4, there's my numerator, out of the 5 pieces. So this would be 4/5 of my whole. The denominator is what I've divided it into, and the numerator is how many parts I have. So today we're going to look at how we can use models to show equivalent fractions. Equivalent has equa in it, which means equal fractions. All right, so let's take a look. Joe cut a pat of lasagna into 3rd pieces. He kept 1/3, so he kept the shaded part, and gave the rest away. And he will not eat all his parts all at once. How can he cut his part into smaller, equal-sized pieces? So pause the video and kind of read through to see if you can figure it out, and then we're going to give it a go. So we're going to draw on this model to show how Joe could cut his part of the lasagna into 2 equal pieces, and then we're going to take a look at if we can rename these 2 equal pieces as a fraction of the original lasagna. So let's take a look. All right, so here's the original whole lasagna. If you can think of it this way, this whole rectangle represents 1 whole. I know it's bigger. It also, if it was to be like a pan pizza, this would be 1 whole. So these 3 pieces each represent 1 whole. So here's your 1 whole, which means that each piece would be how much? Well, remember that denominator is what we've divided it into, and we divided it into 1, 2, 3 pieces. So there's my denominator. All right, and then each one of these would be 1 out of the 3 pieces. All right, so we learned that he's not going to take, he gave these away to his friend, so he no longer has these for him. So he's just going to keep this piece. So how can we break this up into smaller pieces for him to eat later? All right, well, the first thing I'm going to do is I'm going to count 1, 2, 3, 4, 5 squares. I have 5 columns down. I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 and I have 5. So my area, which is my length times width of this part, is 40 units. Okay, there are 40 little units. So I can easily cut this in, right? So if this is 1/3, I can take this whole lasagna and I could go 1, 2, 3, 4, and I could cut this right in half. All right, so what did that do to the original lasagna? Well, instead of now this lasagna being cut into 3 pieces, do you see now that it's now cut into how many pieces? 6 pieces altogether. Do you see that? 1, 2, 3, 4, 5, 6. But he still gave away this part, didn't he? So now I have how many 6 left? I have 1 6 for him and 1 6 for him, which is the same amount, do you remember, as the 1/3. So these two together still equal 1/3 of the pizza. We've just cut up 1/3 into 2 parts, which makes them both worth 1 6. So 1 6 plus 1 6 is equal to 1 plus 1 is 2. The denominator stays the same, which is the same as equivalent to 1/3. All right, so that's what we're looking at when we're looking at equivalent fractions. We're taking a look at what parts have the same amount. So let's take a look at our bars. See if this can help you out. All right, so here's my 1 whole, right? And I cut up my 1 whole into how many pieces? 2, which is my denominator, and I have 2 out of 2 right here, which makes 1 whole. 2 out of 2 is equal to 1 whole. But I'm going to take one of those pieces away. So now I have 1/2 left. I have 1 out of the 2 pieces. Do you see how that works? I'm going to use my lines a lot better. All right, so an equivalent fraction is one that's equal to that 1/2. So I'm going to try my fifths and line them up. And I'm going to find that they don't work evenly, do they? To be equivalent, it has to have the exact same amount, the exact same value, the exact same length as this 1/2. And as you can see, the 1/5 are a little bit over, and the 2/5 are a little bit less. So I'm going to try 1/4. And if you see, that's a perfect fit. So 2/4 is equivalent to 1/2. They have the same amount. All right. Do you think we have any other equivalents? Let's try thirds. Nope, that didn't work out. Those thirds were too big. What about 6? There we go. Take a look. Perfect fit. So 1/2 has an equivalent of 3 out of 6. 3/6 is the equivalent of 2/4. So when you talk about equivalent fractions, you have to find the fraction that has the same value. But notice the denominators are different. Do you notice any pattern? Let's try one more. I want you to make a guess. Do you think an 1/8 will work? Let's see. There you go. So 1, 2, 4/8 is equivalent to 2/4, which is also equivalent to 1/2, which is also equivalent to 3/6. Do you notice any pattern? So this was saying I can use renaming. So in my case, I could rename 1/2 as 4/8, or rename 1/2 as 2/4, or rename 1/2 as 1/2. Well, that wouldn't be renaming, or rename 1/2 as 3/6. All right, let's go on to the next problem. All right, so now we want to draw on the model to show how he could cut this part of lasagna into 4 equal pieces. So remember, originally he cut his lasagna into 1, 2, 3 equal sizes, and we cut these in half, and we ended up with, instead of 1/3, we ended up with 1/6 and 1/6. Now I noticed when he drew it, and we drew this lasagna, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units long, and 1, 2, 3, 4, 5, 6, 7, 8, 8 high. So I did the same model here. So that's what this is. So those lines you see, this right here would be the part of the lasagna he kept. And these 2 slices here would be the part that he gave away. And each of these slices, because I broke his whole into 3 parts. So if I had the whole lasagna, that would be all 3 slices out of 3. Now remember, we took this lasagna first and we sliced it this way. So now instead of 3 out of 3 slices, we had 1, 2, 3, 4, 5, 6 slices. So now I took that, and my whole pizza would have had 6 out of 6 slices. But remember, he gave these away, right? He gave all that part away. So how many 6 were left? 1 6 and 2 6. So he actually cut it up. Now it said, well, can we keep cutting up this into even more pieces? Well, let's take a look. I have 1, 2, 3, 4 measurement here, and I have 1, 2, 3, 4 on this side. So I can cut these 4ths into halves, right? And I would continue that down the imaginary lasagna. So how many slices can you see that I've cut the lasagna into now? All right, instead of the 1, 2, 3, or the 1, 2, 3, 4, 5, 6, how many slices do you see now? All right, well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've cut the whole lasagna into 12 out of 12 slices. But remember, he only kept how many? He kept 1/3 of these, which then we had cut up into 2 6. These were your equivalent fractions. But now how many 12ths do we have? We have 1 12, 2 12s, 3 12s, 4 12s. So 1/3 of lasagna is equivalent to 4 6, which is the same as saying 4 out of all of the 12 he had originally, because remember, he gave these away. So that's how you model equivalent fractions. You create the model, the whole value, you break it up into parts, which is your denominator. Okay, you find out how many parts you have, which is your numerator. All right, and then you can still break it up as long as the pieces are equal. And that's what makes fractions division. So again, we had 1 whole, then we divided the 1 whole into 3 pieces, and we have 1/3, 2/3, 3/3. We kept 1 of those thirds. Then we took the whole and we cut that in half into 6, and we had 1 6, 2 6 out of all of it. And then we took the whole and we cut it up into 12s, and we had 1 2 3 4. So this denominator is like the divisor. It's what you cut your whole into. Okay. And your numerator is how many parts of the whole you have. All right, well done, you guys. Let's see where we are. So again, fractions that name the same amount are those equivalent fractions. So we did 1/3, then we did 2 6, and then we did 4 12ths. Those were all of our equivalent fractions. They all represented this same amount. They all represented the same amount. Next slide. And then it says, compare the models for 1/3 and 2/6. How do the number of parts relate to the size of the parts? Ooh. So here's our 1 whole, and we cut it up into 3 parts, and I have 1 of them. And here I cut up my 1 whole into 6 parts, and I have 2 of them. And here is an equivalent fraction. 1/3 is equivalent to how many 6? 2 6. Here's the same thing in a pizza model. Here's 1/3. And there's 1 6, 2 6. So this is also equivalent. You can see how they work together. So the question became, how do in equivalent fractions, how do the parts relate? Well, one of the things I noticed is that for my 1/3, I had 1 out of the 3 pieces to make 1/3, but to make the 1/3 out of 6, I needed 2 of those 6 pieces. So 1 6 is equivalent to 2 6, but I noticed that these 6 pieces, even though this is a bigger number, they're smaller because I broke up this whole into a larger number of tiny pieces, right? So this 12, here's a really good example, will be even smaller. Even though this is a bigger number, the denominator, it's because I cut this into more pieces. So that denominator, remember, is what I'm dividing this into. So I noticed that when I have a larger number on the bottom, I might need more of them because they're smaller pieces to make these other equivalent fractions. So again here, even though this is 1/3 and this is 6, I need more 6 to make a third. So that's how that relates together. The larger the denominator, the smaller the pieces are. So I might need more of them to make those equivalent fractions. Well, can I make equivalents with my 12s? Well, look at that. 1 6 is equivalent to 2 12s. So 4 12s would be equivalent to 1/3. Describe how the numerators are related. Again, they're related because this was a larger piece, this 1/3, so I needed more of these smaller pieces to make it. And does 1/3 equal 3/9? Explain. Go ahead and give that a go. Pause the video and I will give it a go as well. You can use your fraction bars. So this one's a tricky one because I don't have fraction bars for 9s, but I'm going to look at this number, and this 9 tells me I'm going to be breaking up the whole into 9 pieces. So I'm going to give that a go. 1 2 3 4 5 6 7 8 9. So here's a whole, it's not the same size as this one, that I have broken up into 9 pieces. And according to my problem, I have 3 of them, right? So I have 1 2 3. That's 3 9ths. Each one of these is 1/9, 1/9, and 1/9. So is that equivalent to 1/3? Well, that would mean I would be breaking up my whole into how many pieces? 3 equal pieces, and I would have 1 of them. So let's see if that works. So here's my 1 whole. Could I break it up into 3 equal pieces? So here's my 1 whole. So let's see. 1 piece, 2 piece, 3 equal pieces. You see each one has the same number of units. And is one of those pieces equivalent to 3 of these 9s? They are. So that's how you could prove it. Remember, I originally took the whole. I broke it up into the highest number of pieces, which was 9. 1 2 3 4 5 6 7 8 9. I took the numerator and decided how many of those pieces I had. Then I took this model, this whole number that was still here, and I cut it up into thirds, and I saw if this 1/3 was equivalent to my 3 9ths. All right, well done. I will see you guys tomorrow and see how it goes, and we'll be taking a look at our centers. Just kind of think through how well you can start to recognize and generate equivalent fractions. Have a great day.